thank you guys for coming. We really appreciate it, and for Mike and Eric online, as well as you, Kirk. Our next meeting is October 15th. I don't have a speaker yet, but I'm working on that. And then just stay tuned for details on a holiday party in November. Dan, Hyatt, and I are working on that right now as well. Every meeting that you in the room attend in person, since you're in the room, you are in person. If you're already an SBE member, you have to attend 2 meetings, but after that, all those meetings count and we'll enter you into a drawing. And at our party in November, and the chapter will purchase an SBE Members Plus membership for you, which is a great deal. So, anyways, we'll just hand it over to you, Kirk. Thank you again. We're so glad you could join us.
Oh, well, thanks for the invite, and I'm glad to do this. And it worked out that I had a mostly new presentation put together because I'm doing several of the SBE NS workshops. So this is, Fred, you can sleep because you've seen this maybe.
But I got to ask, how's attendance at Madison?
Well, I'll preface by saying, in the past, it's been fantastic. It's an amazing show. So it's definitely less this year, but I don't have a head count. But I still see a lot of people. There's a lot of excitement. It's great seeing the same people and a few new people. So I think head count is probably lower. So, all right, let me hit the share button here. And, all right. We tested the audio a few minutes ago. So according to Mike Kernan, it works. So the topic here, this is actually a presentation that I've done once. I'll do it again. And I'm also taking this presentation to Calgary, Canada, to the Western Association of Broadcast Engineers, where I'll have a co-presenter who will give some additional real-world examples of stations that are implementing a software-first approach for today's radio air chain. And we came up with this phrase, software first, as a deliberate choice, as opposed to a virtualized approach. A lot of the word virtualized doesn't seem to be resonating with a lot of people. And we engineers in broadcast, we have a real affinity for boxes that you take out of a cardboard box, put it in the rack, put some screws in it, attach some connectors to the back. I got to say, that it's certainly easy to think about and something that we've done for decades. So we're trying to figure out how to get people comfortable with a different approach without making people feel nervous about not having boxes. So anyway, let's move on here with this and see if I can make the next. There we go. So we've had boxes for decades, right? A lot of us probably still have an Optimod 8100 FM in their rack. Hey, at one of my stations, I've still got a Telos 2X12. I'll bet almost all of us have the blue Sage digital NDEC box. Let me ask for some feedback real quick. Can y'all hear me okay? Because I'm in a noisy place, and I don't have any side tone. So
we can't even tell you're in a noisy place.
Okay. I'm sorry, say again?
We can't even tell that you're in a noisy place.
Well, how about that? The amazing of noise-canceling microphones, even if they are $29. All right. So we all still have this Sage digital NDEC box, and certainly some people would love to see at least the option to replace this box with some software that's maybe running as part of something else. Maybe it's part of your transmitter. Maybe it's part of your audio processor. Maybe it is a standalone box. Maybe it's running as a container on a Linux server. Don't know, but people do want some options instead of being regulatorily bound to a physical box. That, we've all had our occasional problems with this, like the power connector that is not attached. It pulls out if you try. It's different issues that we've had with this box that's important to the whole chain. So for decades and decades in broadcasting, the console has been the center of everything. We always think of the console as typically the arbiter of what goes on the air. Now I know you might have a routing switcher after that, but plenty of stations don't. Plenty of stations for decades, the console, it had to go through the console or it wasn't going on the air. But for plenty of radio stations, and I've certainly engineered for some of these, this was the central wiring area of the radio station right here. And that's a shame, but that's the way it was for a whole lot of rural and small town stations. And I'm sad to say even some that I was responsible for. Maybe not even a routing switcher of any kind after this. Well, I want to show you a little video, a little 4-minute video that we produced with a brilliant guy, Dan McQuillan of Broadcast Bionics. And instead of going to engineers and asking what they wanted, he went first to the talent and asked them what they wanted to be in their new studios. So here's what he says.
One thing is still the same year after year. It's about the individual behind the microphone being able to communicate with the people who are listening online, on their phone, in their car, on their radio.
So we asked the question of a major European broadcaster of what would the talent in the studio really like the future of their technology, the future of their studios to look like. And the answer that came back was not what we or the broadcaster was expecting, but there were two clear things they wanted. One was cushions and the other was daylight. Hi, my name is Dan McQuillan from Broadcast Bionics, and today we want to talk about the Bionic Studio. That's the future of radio production, fitting it to reach and retain an audience of distracted listeners, and also helping you to measure and monetize all of those different platforms that radio now needs to reach. So a Bionic Studio means a studio which is listening and watching and reacting to what's happened. So rather than the technology merely being passive, it's part of the production. I mean, if you think about it, you wouldn't hire a producer and then sit them down the hall and have them not listen to the program. They couldn't be much help, but that's basically how the technology has been. It's been passively inert in the studio. But now through intelligent and fast transcription, the studio can react. It can understand what you're saying and automatically detect topics or segment your program. Using face detection, we can recognize who's speaking on cameras to help to generate the metadata that lets us drive more intelligent programming. So a Bionic Studio looks and works in terms of your operation exactly the same as a passive one, but the tools that you're using are able to react in context. You play a particular song, we can react to that song by pulling more information and control into the studio. It's about capturing the very best moments of radio, those intimate moments when the voice breaks and you know a caller's going to cry, when you have something that just has that driveway moment, when you can't exit the vehicle because there's that compelling moment. And now I want to make that content shareable and searchable so it reaches a whole new generation of listeners and is discovered in just fantastic and exciting new ways.
My experience in a control room is pretty simple. The less I think about the technology, the better off I am, and the better my show is, and the better my performance is.
To lead in our world, it's all about innovation. It's what's that new, next big idea. Anytime we get to take our content and spread it, that helps us create word of mouth, or as it is now, online digital postings and social, that gives us the greatest promotional tool ever. And that's something we're all trying to embrace.
Essentially, radio is a document. It's just a spoken document, but we've considered it all along to be audio. So by transcribing it, that audio becomes searchable and discoverable, not just to audiences, but to us within the radio station. So we can search for, someone said banana yesterday, that's fine. They said it at 17 minutes past 10 in the morning and exactly this many milliseconds. So it's not just accurate transcription, it's time accurate. So now imagine you can edit your entire show just by clicking on the words or the script within the show. That's actually all you're really doing using a waveform editor. It's just that you're having to map between squiggly lines and what was really essentially a spoken performance or the words that happened. So it makes radio searchable, which is fantastic. It makes it fit for sort of closed captioning, which is the way that now people often read Facebook audio before they actually click and hear it. And importantly, it makes it time accurate so that you can do your job just by clicking on the words that you said, whether that's searching for them or using that as an in and out cue to edit. I think we can create an even more intimate environment for radio. We don't want to get rid of all the technology, but we need to smarten it to a point where it becomes less of a distraction. And I think the whole cushions and daylight idea was, can we actually make this a more comfortable and natural an environment, not just for the talent and presenters, because we're kind of used to this stuff, but I think when we're interviewing people and we're inviting guests into our space, if we were sitting surrounded by cushions and daylight, I think what we would get out of our guests and the way we appear to our audiences would be transformed. There's nothing wrong with the way we make radio. We want to help you to make it smarter and better and fit for all the devices that we now have to hit. So thanks for giving us your time. We're trying to start what we call the creative conspiracy. That's engineers working with talent in the studio to take technology and help really to improve content and have it do exciting things. So if you want to join the conspiracy, you can see what we're up to. Our website is bionic.radio, or hopefully we'll be in touch to find out how we might be able to help you to build a bionic studio for the future. Thanks for listening.
So obviously this is kind of inspiring, and I love being able to share this kind of content. Let me see if I get to the next. There we go. So it's just to give you a vision, maybe a little pie in the sky, what is possible, what can we do to make better content, and how can we as engineers help that to happen. I'm going to talk about a few technologies that are out there right now, and one of them is virtual mixing. Here's a picture from a radio station that I'm part owner of in Greenville, Mississippi. Just shows how you can add another mixer to a studio without adding another control surface. So you can do things like mix sports events or holiday programs, or monitor and control other stations in your cluster. And certainly there are stations that I've been to that are doing this right now. I've been to a station in Portland, Oregon, where the program director has one of our virtual consoles in her office. So she doesn't have to get up and run down the hall to fix something or do something, or listen to something that may be in preview. She can just do it from her desk. When it comes time to replace older hardware, this is actually a picture from my station in Cleveland, Mississippi. And it's an old Element console that's off to the right there. You can't quite see it, but it's going to die someday. I mean, we've replaced the power supply once, and it's probably close to 12 or 13 or 14 years old. You know what? It's 15 years old. So we could replace it with literally a touchscreen and an engine mixer that's running in software back in the rack room, because the whole facility is audio over IP. It's live wire. It would also work on AES-67 as well. So you can certainly fit this into small rooms or retrofit, and it uses commodity computer hardware for the control. So if the touchscreen ever dies, well, you buy a new one. They're literally now as little as $120. I just bought one about 2 months ago for $120. The better ones are $350 or $400, but the cheaper ones can work too. Or you can use, again, some existing technology. Chris Green is touching this screen, but it's not a touch screen. He's going to have to grab the mouse to actually manipulate some controls or move a fader. But this lets you, even do your job from your office if you need to get that done. Here's Chris Green again. Actually, we moved him to another radio station. I'll have some more information about this station for you later in the presentation. We had a real challenge here at the station, WBZK, in Oxford, Mississippi, home of Ole Miss University. We were not allowed any kind of STL antenna on the studio building. And the internet provider at the studio is AT&T, and the internet provider just 4 miles away at the transmitter site is C-Spire. Both are terrific, but to talk to each other, they got to go through, I don't know, Houston or New Orleans or something like that. And there's been times when the connectivity between the two has not been perfect. So we elected, and I'll have more of the story later, but we elected to put all of the radio station's equipment at the transmitter site. And so every morning for 4.5 hours, Chris Green does a 4.5 hour remote from a studio that looks just like a main control room, except it's got touchscreens. He's got 3 mics in there and 3 headphones, and does his production, and anyway, it works real well for him. But here's a couple other examples. These examples inspired me 2 years ago to build WBZK. There's KZLF in Alva, Oklahoma, a station that's owned by a couple of IT guys, and they bought this radio station, and they run the station's infrastructure from their own small server facility that's not in the radio station. It's elsewhere in town. And then KZOZ, which is in San Luis Obispo, California. The morning team had to break up. The guy who ran the board for 14 or 17 years, his wife got a great job in a different state. So it was either stop the morning show or continue doing it remotely. And so the guy who moved in Washington State does the show from literally his kitchen table, and he has complete control of the console from his home. Jason Aldean, he has built a second kitchen and rooftop bar, this one in Gatlinburg, Tennessee. And he invited Summit Media to put a studio in the restaurant. And so they've done that. We'll have some more story on that coming up with a live interview. So again, we've been really having, console-centric studios for decades and decades. And when we do things in a network fashion, and those of you who have done network studios, you already know this very well, it no longer has to be all about the console. Rather, it becomes all about the network. And fortunately, networks are built with more or less off-the-shelf, if not commodity hardware. And so we can do some pretty amazing things for some much lower prices. Let's see here. Oh, yeah. We've gotten very used to, by the way, normally I have my speaker notes, but I'm operating on one computer here, so I don't have my speaker notes. So I'm either trying to remember what my slides are about or making things up as I go. We're for almost 30 years now, we've had automation systems running on computers. So, yeah, we're very used to using computers to run our radio stations, at least in some sense, at least certainly in the automation sense. When we think about, though, hardware versus software and the life cycle of hardware and the life cycle of hardware and software, when hardware dies, if you have, we gave an example earlier with the Orban 8100. When the 8100 dies and it's no longer fixable, or the Telos 2X12, when it dies and it's no longer fixable, not only do you lose the hardware, but you lose all the intellectual property that went into that the hardware is running. You lose that investment, and there's not really any way to recoup that investment if the hardware dies. But if you have software and you're running it perhaps on your own hardware or on hardware that you can still buy, if the manufacturer allows you to, maybe if you have a contract or something, or a service level agreement, you don't lose that intellectual property investment. You can keep that and move it to new hardware, which is what you do anyway with your laptop or other programs that maybe you've bought and paid for, and especially more specialized programs that you may have had a buyout, paid a pretty penny for. You can move it to a different machine, even if it's licensed. Oftentimes or usually you can move that. So I thought about some pros and cons of traditional hardware. So what are some pros of hardware? Well, it's purpose-built, and I guess that's a good thing. It's meant to do exactly what it's doing. Cons, though, it's purpose-built. that can be a downside. That means it can't do anything else, and it may not be improvable in any meaningful way. Pros, in the broadcast industry, your gear is built in small batches. The downside of that is that, your gear is built in small batches, and that typically means it's more expensive than commodity hardware. Pros, traditional hardware is mostly reliable. I think most of us have enjoyed excellent reliability from a lot of major manufacturers, whether it's a Continental transmitter or an Orban processor or a Telos phone system. I think we enjoy reliability. The downside, though, of purpose-built traditional hardware is that it's going to become irreplaceable at some point. And COVID really taught us that. A lot of manufacturers of parts slimmed their product lines, and things that we could buy in 2020, we could no longer buy in 2022. They just were not being made, and they weren't going to be made. The intellectual property inside a traditional hardware, it's tried and true. But the cons are the intellectual property dies with the hardware. Pros, made of real parts. But the cons of traditional hardware is it works best the day it was brand new. And after that, you get to enjoy years of degrading performance. And we know this, from especially from analog audio gear. But then digital gear, a lot of it will reach a digital cliff at some point and quit inputting or outputting at some point. And what about the manufacturer? Well, when a manufacturer makes traditional hardware, his costs are multiplied by the number that are sold. And we'll see the juxtaposition of that here in just a second. What about pros and cons of virtualized systems? Well, the pros, very purposeful development. I mean, you got to focus on that software, on that code. You got to approach it right. Maybe you make a mistake in the way you first approach it. The downside, I really couldn't think of a downside to purposeful development. I mean, you wouldn't have haphazard development, so that doesn't really count. Easy testing and improvement. Yeah, software is pretty easy to test. Sometimes something gets missed, but we can test for a lot of stuff. In fact, at Telos, that's one reason why we hired the University of Riga in Riga, Latvia, to do testing, regression testing on our software, because they could run it through millions of scenarios that try to make it fail, that we couldn't. And that's one reason why the mixing engine technology at my employer, Telos, why the consoles has been really, really good because of that testing. And you know, the con is, well, you know, complex software does require testing. You have to test it. Otherwise, you're going to, you know, you don't want to make your customers do the testing. And I know for some of you, it feels that way. It feels like, what are you making me do the testing? I found this problem. You never heard of it before? I get that. But we do catch an amazing amount of stuff early in the process. Pros, well, you can get industrial strength uptime. The cons, it's got to be in the proper environment. You know, the software operating system environment that it's running in has got to be right. It's got to be what the manufacturer expected, or at least you know, approved by the manufacturer. One of the pros, the intellectual property is relocatable. The downside is, to be relocatable, you may need to pay for an extended warranty to have convenient relocation. The pros, you know, you should get years of improving performance as patches come out and new features come out. You should be on the enjoyment part of that equation. But again, it may cost dollars, depending on the manufacturer, for them to continue to update you with new features. Now, the benefit for the manufacturer, well, instead of being multiplied by the number sold, the costs are kind of divided by the number sold. Now, we still have to keep developers developing, and they all require salaries, but at least we're not multiplying each individual unit by the number sold, by the cost of the number sold. I want to mention power supplies. You know, so many pieces of equipment still just have one power supply. Wouldn't it be great if every piece of equipment had dual redundant power supplies? That would be cool. Certainly in the IT world, in the industrial IT world, everything does. Some pieces even have triple redundant power supplies. And some, because they're in a compute environment, they can tell you their status remotely. So you don't have to go look at the air filter or see if a fan is running or go walk by the server to see if there's a flashing yellow or red light. They can tell you remotely about the status of the power supplies. That's a real benefit to smart power supplies. So virtualized infrastructure, what might that end up looking like? You know, for decades, you and I too have enjoyed the variety and creativity of different boxes, different colors, different knobs, different manufacturer designs. We appreciate different aspects of this, and I appreciate all the intellect and design philosophy that's gone into so many different products. Whereas with a virtualized infrastructure, you know, the boxes all end up looking the same, like this. But this is actually a good thing for servers, because servers are designed to be generic. They're pretty well interchangeable. So this is one reason why the HP salesman or the Supermicro salesman can come by your Dell facility, and he has a chance to sell you on changing servers to a different brand, because the HP or the Supermicro servers should behave very similarly and should run all your software just fine. But in a virtualized environment, your different functions might end up looking something like this. You know, a lot of, or almost all the air chain can already be virtualized right now. Let's see, not shown here is the automation system. That would be elsewhere on the network to the left. But we can do audio consoles, phone systems. My little station in Oxford, Mississippi, the phone system is virtualized in the same Linux computer that the console is virtualized in. We have intercom systems, profanity delay, of course, audio processing, audio streaming, watermarking, RDS, all that stuff is virtualizable now. And in fact, you're probably using cloud stuff already. Not that virtualization has to be in the cloud. It's easy to conflate the two. But many things are already in the cloud. Your website's in the cloud. That's not sitting on Mary Lou's computer in the accounting office. Your listener database is probably in the cloud. On-demand shows that you may record and put online for on-demand. Your live streaming CDN is in the cloud. If you do payment processing through Stripe or FreshBooks or whatever, that's in the cloud already. So I interviewed right near the end of COVID. I talked to some engineers. A large group engineer says we will likely never buy another rack-mounted phone hybrid. We could likely buy some more rack-mount audio processors, but phone hybrids, no, those are going to be virtualized. COVID has certainly accelerated remote work, and they're doing more sharing of facilities. The studio is now shared among stations. Some of you are probably doing that already. Certainly, even in my small markets, we'll typically have one studio for 5 stations, and we'll share that studio throughout the day as needed. Here's a good example of a shared studio. This is Capital FM in London, and they literally push a button on the right-hand side of their Axia Fusion console, and the room looks like this just a few seconds later. They do have to go change the mic flags. In fact, in this picture, I just noticed the mic flags are still the Capital FM mic flags. They didn't go around. We just changed it for the picture. I wanted to see how that worked. If you want to do 100% cloud or offsite, this is what a diagram might look like of how that could work. Sorry, I've got to move this out of the way so I can see better. You'll have a virtual mixer, perhaps in the cloud or perhaps in a data center, your automation play out. In a data center, the audio connections among things are typically going to be AES-67. And typically, they're not going to be LiveWire or WheatNet. They're going to be AES-67. But you can certainly have a simple setup like this with your audio processing, and then use micro MPX would be one way to come out of the cloud as a full MPX signal, and then go to your transmitter site for decoding into analog baseband for that purpose. Oops, let me get back. If you have remote workers, you can certainly do that with the Axia Altus console. It will do WebRTC, and that means any computer you have that's running a modern browser since 2018 is going to have WebRTC available, and it's going to have an Opus codec built into it. And so you don't need anything else at the remote site other than a computer with a browser. Even your phone with a browser has WebRTC built into it, or a tablet. So that's certainly one way to get it done. All right. Sometimes I have a little trouble kind of defining what virtual audio processing is versus hardware audio processing, because, hey, since for many years, your audio processor has been running an operating system and running software that was meant to, in that environment, meant for that specific hardware. So I talked to Jim Kuzman. He works for Telos, and he had a really good definition of what is virtual audio processing.
Well, when we as Telos Alliance talk about virtualization, what we're really talking about is taking proprietary hardware out of the equation. So in the case of Omnia Enterprise 9S, we have a product called Omnia 9 that has hardware. It has built-in front panel with a screen, power supplies, proprietary I/O, all built into the back of the hardware of the appliance. So when we talk about a virtualized version of this, it's all of the same processing, all of the same software, all of the same sonic capabilities of that hardware product, but without the hardware.
All right, without the hardware. Let's see here. I don't have my notes. Oh, yeah. I'm going to turn this audio way down. So this is a group of stations on Maui that I just built about 10 months ago. And although we don't have any big servers here, we've got a couple of file servers, everything is on LiveWire. A couple things are AES-67, come to think of it. And we bought a selector there so that I can even send the general manager in there to listen to any feed that's on the network. I've got the 6 buttons pre-programmed for our 6 main radio stations. And in this particular case, so much is virtualized. The audio processing is virtualized. Of course, the playout, automation playout, just by nature of what they are, they're virtualized, if you will. And I decided not to use big servers. I used individual Lenovo ThinkCenter computers to run everything. It's kind of 6 of one, half dozen of the other, but in this case, it seemed to be a better choice. Right there, we just passed by it. And then the streaming and the on-air logging. That's a view of the streaming and a view on the right of all of the logging of all the stations. So there's not too many items in there that are dedicated hardware. There's a couple of Innovonics tuners so I can listen remotely. Of course, there's the Sage NDEC, as we talked about earlier. But so much is virtualized. In the last couple of years, you've probably heard us bring up the word containers and try to explain that juxtaposed with virtual machines. So I asked Greg Shea, he's our CTO at Telos, if he would explain what's the difference between a virtual machine and a container.
Why virtual machines and containers? Why do we have both? And why would you want to use containers versus virtual machines? Well, the short answer to that is if you've ever set up a virtual machine, there's a number of things you have to configure and click on and things to think about, virtual peripherals. It's rather like setting up if you bought a new computer. A container is trying to achieve the same goal, that you don't have to buy another physical computer. You want to be able to run the software independently, the installation being independent, so you don't have a conflict between other stuff that's on that computer. You want this place that's the container to run the software that you want to run. And the difference is, with containers, it is a more limited set of stuff that you have to set up. In fact, it's also designed to be automatable so that you don't have all those choices to make about all the peripherals and all those various things of setting up about a virtual machine. So a virtual machine is more comfortable if you're thinking in terms of setting up a whole computer and a whole environment for a piece of software. But a container is a very strategically designed piece of a virtual environment that allows you to run the software that you want to run with a minimum of other stuff, a minimum of overhead to worry about. So it's kind of more of a contained package, thus container.
All right. The future of computing services. Well, if you send me some money with PayPal, it's going through containerized processes. A couple of years ago, maybe 3 years ago, that summer, my then girlfriend, now wife, Carmen, and I and my son all went to play putt-putt in Murfreesboro, Tennessee. And there was a family behind us, and I got to chatting with the father of the family, asked him what he did. He says, I run a data center here in Murfreesboro for a major healthcare company. I said, the company I'm working for, they're introducing broadcast infrastructure products in containers. Do you guys use containers? He looked at me, he said, that's all we have is containers. Everything is containers. I said, don't you have any virtual machines? He said, I think I've got a virtual machine environment on my laptop, but no, everything is run in containers. And of course, they use big management systems like Kubernetes and maybe other things too to manage those. With broadcasters like us, we tend to use a free tool like Portainer to give us a view of several containers inside something. But to me, it was all new, and to him, oh yeah, we've been doing this for years. Got another good explanation here. I like the way Jake Alderman talks about this. Jake was a broadcast engineer until he started working for us at Telos. In fact, he worked several years at WGN Radio in Chicago, and he talks a bit more about containerized software.
Containerized software is a new method for deploying software in a more lightweight manner. So traditionally, we had applications that installed onto an operating system and would run on your desktop computer or a server, and we're all used to those in the broadcast environment now. And in the last 10 years or so, we've started to see some people use virtual machines, and that's taking a physical piece of hardware and making a virtual version of the computer, installing the operating system, and then installing the application on top of that operating system. Containers are a middle ground between those two. What we're able to do is, instead of virtualizing the whole machine, we're able to create an isolated place to just install the software we need, like an audio console or a phone system. And so what we do instead is we share the operating system, but we have this isolated bucket so our audio console doesn't touch anything else. And it's not actually called a bucket, it's called a container. So you've got your container that holds your one application in isolation, similar to a VM or a physical computer, but it's able to share the resources of that greater compute platform.
All right. So it might look like this in application. You'd have, you can provide your own generic server if you like. Host operating system is going to be Linux. And then the Docker runtime engine is going to run on that. And then it's going to service whatever containers that you've put in there. For example, the Axia Altus container, which is an audio console, we only need one CPU per Altus. So we can run a 24 fader console with auto mix, with mic processing, with automatic mix minus, the whole console on one CPU instance. So if you've got, you know, a 24 cores of CPU in your server, yeah, you might need 2 or 3 cores for the operating system and the overhead, but then the rest of them you can dedicate to consoles or a phone system. Phone system typically takes 2 cores. Let's see. Of course, you know the typical layout of an audio over IP system like this, where you have a core switch that handles all the packet routing, and then you've got external devices, whether they're Wheatstone blades or Axia X nodes. You've got computers running a driver, like the Axia IP audio driver, and then you've got an audio console that, under direction of the surface, it'll tell the engine, hey, subscribe to this feed, subscribe to that feed, you know, microphones, phone hybrids, automation PCs, mix them together at this level and put them out a new output, maybe called Program 1, and make that available to the network. We can, once we have things on the network, we can add another console. This is an Axia IQX. It happens to have the mixing engine built into it, so literally one cable to the network, and you can subscribe to anything that's already on the network, or you could, on a second port, you can add a local node in the same room if you want to. Well, we got to thinking, what if we could replace the physical surface with a piece of hardware? So actually, for quite a few years, we've made something called the soft surface. And there's a developer and our dealer in France. In France, they really love this, and they have something called IP Studio. So they can make a very customizable control surface that runs in a Windows environment on some kind of tablet computer or on a big computer. Or you can use something like Pathfinder from Axia to create a panel of faders. Well, then we thought, what if we go a step farther and we actually replace the engine? Remember in the previous slide, there's that mix engine in the lower left-hand side. Well, it's just software running in an environment that we know a lot about. What if we virtualized that and made it run in containers and ran it on a host operating system like we saw a couple slides back? So here are 6 Altus audio consoles. Each one of them, of course, is a mixing engine with all the things required to do that, but each one also has a web server. So you just browse to it and you're presented with a console that is outfitted by whatever you've licensed it for, however many faders you've licensed it for, and then you can just use a browser to browse to it. So you've got that console in the upper middle there that's represented on a laptop, and it's not high bandwidth. We're not sending LiveWire or any AOIP to the laptop. We're just looking at and controlling the mixer, which means that our data rate here is pretty reasonable. We don't have to be on the LiveWire or AOIP network. We can use the public internet and browse in remotely, as shown in the upper right. Or we can even be on Wi-Fi, which you really can't try to run LiveWire or AES67 or WheatNet over Wi-Fi, but you can run the console over Wi-Fi. So that gives you some options there. I want to play for you this little clip from Chris Green. Chris is a great morning host. He is so creative. He will never be an engineer. There's no possible way. But maybe you've got some guys working with you like this who are very creative types, who he's trying to explain his experience here with it.
Man, it's so cool. When we got into it, I was like, I feel like I'm in the future right now because I've only used traditional boards with sliders and faders and buttons. And initially I was like, man, am I going to miss that? But as soon as you use Axia Altus for a little bit, you start realizing how responsive the touch screen is. I mean, sometimes when you're about to jump on the air and you need to hit your fader up, instantaneous. I mean, you get amazing reaction time with just a slight twitch of your fingers, and it has been the transition was quick, and I can't imagine going back to a traditional mixer board.
All right. So when you design a console, or it doesn't have to be a console, whether it's a phone system, a console, a codec, you can break the rules that you've been kind of fixed with for a long time. So when you design a console, we can do things that normally would be cost prohibitive. Hey, if you've got an Axia Quasar console, you know that you can get the pre-fader metering, the input source metering next to each fader. Well, in a software console, we can do that for free. It's a few lines of code, right? So next to each fader here, you can see the audio level that's coming in to each fader. We can also make things, there's the program mix meters. We can make the buttons context sensitive. So for example, on audio sources that you can't talk back to, well, there's no talkback button. But there is an option button for all or most of them. There's drop-down menu source selection. You can hit that drop-down, choose different things. There's that confidence metering of what's coming in. The channel slider, one thing we kind of figured out is that we don't have to make the user target a knob represented on a screen. With this console, you can touch anywhere in the sliders area, and it will pretend that that's that you're going to start there and move up and down. So you don't have to be as accurate with your touching of the screen. Also, we can, at literally zero cost, we can build in a phone controller. So if the show definition for the show you're running includes one of our VX phone systems, or even our older HX phone system, then we'll give you controls for it. And the controls move wherever you want them to, or they move, next to the phone fader. So if somebody wants the phone faders in the middle of the console or on the left, the phone controller moves along with the phone fader. So that's kind of cool. All right, what's next here? Context sensitive. Oh yeah, you can keep the jock away from this, or you can give them access to input gain, balance, auto mix weight, for example. EQ controls, and again, you can lock people out of this as well. The dynamics controls, threshold for the mic processing, and so forth. Okay, but just some things that you can do with a virtual console that could be cost prohibitive with anything else. All right, what about touchscreens? I get a lot of pushback. People saying, "Oh, yes, well, my announcers won't like that touchscreen. They're older people, and they've got to have physical knobs." Okay, I get that. I talked to Jeff McGinley. He's now VP of Engineering over at Summit Media in Birmingham, Alabama. Same group that put the studios in Jason Aldean's kitchen, and here's what he says.
It took the morning show about half a shift on one of the stations. The afternoon shows took about 5 minutes. They took to it really quick. They were very appreciative of the Livewire upgrade for everything else. There had been some. It had been kind of an older facility, and so there were some nagging issues that were going along with the older technology. So we were able to not only give them new stuff that they really enjoy, but we were also able to fix a number of other things that they've just learned to live with over the years. So no pushback whatsoever. They were extremely happy about it.
So you might remember from a presentation, 2 or even 3 years ago, Jeff also had to move a bunch of stations in Portland, Oregon. Same question came up about, hey, will the jocks take to using touchscreens? And he had the same story there. He said, yeah, it it took them a short time, less than a shift, to get used to the touchscreen and be perfectly comfortable with it. So here's a concept. With traditional physical audio consoles, you kind of know where things are going to go. We're going to set the console here, right over this big hole in the table. And we're going to put the mixing engine for this in the rack room along next to the Ethernet switch and the other gear. So you know where it's going to go. Well, that's pretty straightforward. That's what we have done for decades here as broadcast engineers. But this is that station in Oxford, Mississippi, and not too different from the one in San Luis Obispo or Alva, Oklahoma. Here's a studio. This is the kind of the showcase studio in a nice office park that does not allow any antenna of any kind on the roof. And we didn't want to depend on two different internet providers to stream audio 24/7 to the transmitter site, which is only 4 miles away. So we took this interesting decision to put everything at the transmitter site, and then the studio would be a remote broadcast every day. There is a little mixer. It happens to be an Axia IQS mixer in this room. It's to mix the mics together to send them as one audio package, if you will, to the transmitter site, and to do production in this room. So the fourth screen down low there, the fourth screen that says OMG, that's the computer that also runs Adobe Audition and run something else too. But anyway, that's where they do their production and they do their morning show. So how can you deploy virtual mixing? Are there some comfortable ways, uncomfortable ways? Well, one way to make it easy or easier for you, Telos sells this box. It's a little mini server called the AP3000, and you can fit like up to 4 mixing consoles on that. You can fit 2 phone systems or 2 consoles in 1 phone system, et cetera, et cetera. You can fit audio processor on that. And the way the sales department has this figured out, if you buy the AP3000, installation of the software is free. It's included with the cost of the AP3000. You can provide your own bare metal server, and that's what I have done at a couple stations. And then Telos, because it's not child's play to install these containerized softwares, especially doing the networking internally, Telos will charge you to remotely install that, but it'll be right when they get done. So that's another option to use your own server hardware. And then if that server hardware dies, you can certainly move to a different server. Broadcast Bionics, that's Dan McQuillan's company, they make a product called Virtual Rack, which is a really neat appliance. You plug this thing in, you browse into it, and it's got like an app store already in it. And it lists all the apps that they know about that can be run in containers for broadcasters. So there's things in there from 2WCOM, and there's some products in there from Sound 4. And of course, there's some things in there from Axia and from Omnia. So you choose the app you want, you click it to install it, and literally in under a minute or two, the app is installed properly with the right networking, and you set the IP addresses that you want it to have. And now it's still not licensed. You still have to go back to the manufacturer of each app you've installed and get their license. But that's one way to do it. It really demystifies Linux because you don't see it. You click and install the apps. And I'd be remiss not to mention our Canadian dealer that has their own fanless platform that they can install all different kinds of applications on, including containerized products from Telos and from others. So there's different ways to get this stuff installed and deployed. And I haven't even talked about cloud yet. There's certainly stations that have put this in cloud. I think it's still a little ahead of the curve to do it there because of some interesting costs that you may not have thought of. But for disaster recovery, it certainly works well. All right, let's move on. I'm gonna move past this and move past this because I just talked enough about those things. Okay, this is the transmitter side of WBZK in Oxford, Mississippi. On the left-hand side, there are 4 Dell 1RU servers. The top one contains the console and the phone system. We're at HD. We're running HD 1, 2, and 3 there. So the Omni 11 is our processor for the FM and the HD1, and I'm going to run that again. On the right-hand side, the blue box at the bottom, near the bottom, that's the file server for the automations. The automations do run in their own workstations. That's just how we were doing it at the time. And then we have a couple of nodes in there. There's an analog node to run loop audio through the Sage NDEC, and then there's an AES EBU node for the benefit of feeding the HD multicast box from Nautel. Let's look at the daily remote that they do from Aldine's Kitchen in Gatlinburg.
So we have a cluster of stations in Knoxville, and we were approached by a restaurant group who was opening up a new restaurant in Gatlinburg, which is about an hour, a little bit more than an hour away from Knoxville. And they wanted us to do something similar. They have a studio and a restaurant that's in Nashville, and then one of our other competing, companies has a broadcast studio that they do for PM Drive Monday through Friday there. And since they wanted us to replicate that in Gatlinburg. So it took a little bit of time getting everything together, and I'm not going to get into the acoustics of the room that were also kind of hard to manage because it's floor to ceiling window, 2 feet away from the mics. But this was perfect. It was a perfect, Altus was the absolute perfect solution for this. So there are 2 stations that share that studio throughout the course of the week. So we did a bit of a LiveWire upgrade at the station and got a good LiveWire backbone going all throughout the studios, the TOC, everything like that. And we deployed the server at the station, and the DJs at the restaurant. They just connect to the server, and they use Altus for the PM Drive show. In the control rooms in Knoxville, we also deployed giant touchscreens for their consoles. So they're using Altus both in the station and out at the restaurant.
Cool. In fact, there's a picture of the studio at Aldine's Kitchen. Challenging acoustic situation there. But you can operate anywhere. Nightclubs, churches, restaurant, bars, outside broadcasts. I have joined literally using a touchscreen Chromebook that I bought for $250. I have joined the morning show on WBZK, and he just brings me up on a remote fader because the link that I follow brings me up on that fader, and I'm really connected to the transmitter site, to the console. But Chris Green, the jock back at the studio there, he just brings me up the fader. He talks to me, I talk to him. Also, we can talk to each other and not be on the air with the mix minus and the talk around feature that our consoles have. So it's really effective. It works well. I could also remote in and control the console at the same time. I think you can have 8 people controlling the console at once if you want to. You can also have people on remote come in using WebRTC and not have console control, but they're just contributing with audio. Let's see here. Oh yeah, it's a little interesting how the phone system works with the console. So let me let Jeff describe that.
Deployed a Telos VX, and it's just coming up on a fader, and then we're using the X Screen software that's basically dialing in, and that's selecting a line. And because of the mix minus, if they're out at the restaurant, it actually operates the exact same no matter whether or not they are in the studio or without. All the audio comes up in one fader. They're able to select the call, and once again, the caller has no idea whether or not they're in the studio or at the restaurant. Sounds flawless.
I think we're drawing close to the end of our time here, so let me punch through a couple of things. This is what we saw a graphic like this before. This is what remote talent looks like with an Axia Altus running the WebRTC. And you can run the WebRTC as a stack yourself. Telos can install that for you. You can also subscribe to third-party WebRTC stacks and use it not only for Altus, but use it for other purposes that you might have. There's a whole industry about that. I'm going to punch on through a little farther to this graphic. I just want to explain that control room. These are the first 3 are touchscreens. The first one, we just use we just have a link, a secure link, and a password that goes to the Axia Altus at the transmitter site 4 miles away. Of course, the packets are going a rather circuitous route through several states to get 4 miles away. There's the Playout 1 remote access. That's also on a touchscreen, same Dell touchscreen, but that's at the transmitter site. And we're just using a remote access program to access that. We happen to use dwservice.net. I like it because it's inexpensive and easy, but we also have Remote PC as an alternative if we need to. And then that third touch screen is the local mixer for mixing the local mics. And you want a headphone mix with 0 delay or very low delay. We don't want the headphones of 3 people in the same room to go to the transmitter site and back, because that would be confusing. Everybody's got delay. Now, if you're a single person out at home by yourself, you're going to have some side tone in your USB adapter box, and then you're going to get mix minus back from the Altus through WebRTC. You'll get that automatically. So kind of some summary here, hardware versus software. This is where a lot of people are thinking about this. I like to say it's a choice. It's not a challenge or a challenger to hardware. It's a choice. Some broadcasters really want or need this. I mean, there are broadcasters on planet Earth that are running hundreds, and I mean like 400 instances of Omnia processing in the cloud. So people are doing this at large scale. Heck, it's been 12 or more years since the BBC actually centralized their mixing consoles. They did it in the latest technology they could 12 years ago, but it was all Axia engines running in computer server blades in London and a backup in Birmingham. So it can be efficient and highly scalable, but I'm proof that it also works well for smaller broadcasters, with whether you're 1 station or 6 or 8 in one place. All right, going to wrap things up here. I'm done with my part of the presentation. I found something cool online. If you're an old guy like me, you may remember this graphic from the Weather Channel on your cable TV channel. Well, the guy, netbymatt.com, he has recreated this, calls it WeatherStar. So if you go to weatherstar.netbymatt.com, snag a picture of that. It's fun to play with. You can customize it to a large degree. It even has the old MIDI-generated jazz music that they were famous for playing. So I thought that was a whole lot of fun. I keep that on a monitor in my garage. And I tell you what, I'm gonna stop here. I think I've used up all my time and probably most of your attention.
Well, thanks so much, Kirk. That was really cool. You guys, anybody there have anything for him?
Excellent presentation. No, very good. Thanks, Kirk. This is much better than last Wednesday.
Okay. Well, I'm not sure I left time for much of any questions, but if anybody has a question that you'd like to pass along right now, I'm happy to hear it.
No, they don't like you, sorry.
As you can tell, I eat my own dog food. So, and by the way, Telos makes me pay for all this stuff. I don't get it free. So they treat me like a customer. So it's okay. It's okay. It's what is that? It's Stockholm syndrome. That's what it is.
Kirk, I have a question for you.
Yeah.
If someone were to virtualize a console and specifically things like engines and processors and the more back office type things, how would they monitor the performance of those things from the engineer's office?
Huh.
Is that an SNMP thing, or do you have a sort of a web interface that you'd leave open, or how would that work?
That's a great question, and it's the kind of thing you really don't begin to realize as part of your workflow until you experience it. So certainly the IT world uses a lot of SNMP, and so there's things about the health of the hardware and the health of a computer process that you could monitor with SNMP. And plenty of people would do that. I talked to an engineer earlier today who deploys nothing but SNMP to monitor the things that he's interested in. Now me, I'm not so much an SNMP level guy. Thank goodness, here at the Madison show a few years ago, Tony Scott Peterly gave us all a lesson in SNMP monitoring and control. And I really appreciated that, and I learned about it. I was really excited for about 10 minutes until I walked out of the room and forgot a fair amount of what I had learned. But I really did enjoy it. Now, there are tools, certainly, to monitor the health and the operation of these things. During the presentation, I mentioned Kubernetes, and a lot of people use that to in IT in server farms to monitor container processes and move them around, bring them up and down as necessary. There's a free app or service out there called Portainer, and whenever Telos installs something, like at my stations in Oxford, in that transmitter room, the first thing I do is I go into Portainer, and I can look at the health. I've got probably about 6 or 7 different containers that are running. Several of them have to do with WebRTC. So there are several in that stack of things to make WebRTC run. But then there's one for the Telos VX, and there's one for the Axia Altus. One time, the Axia Altus wasn't responding properly. I don't know why. I think it was an internet problem at the station, but I thought, well, I'll reboot that container. And it's easy to reboot a container, just make it start over again. And it's when you tell a container to reboot, it happens it seems like it was 3, 4, 5 seconds and it was back up. So an IT guy might keep Portainer or something like that up and so you can have a quick look at that. I keep nothing up. I mean, if I browse into that machine remotely, it's just the Linux desktop. And there's usually a warning that I need to update some modules or something. I haven't yet. So I hope that answers it. Of course, you can browse into the same UI that the disc jockey's using. So you could browse right into the console, right? Or you could browse into the screens for setting up the console. So the traditional Axia screens that you may be used to, you can browse into that and look at sources, show definitions, outputs, all that kind of jazz.
I think we've gotten used to situations where, things will stop running and, they won't be something that's used front and center every day. Let's say an EAS process. And then, you go to it and it's not running. I've employed software to just keep an eye on some processes that run in the background. And I was wondering if, like things that run on a container, if, say, they get stuck, how would one know until the point in time when they go to send that EAS test?
So of course, with EAS, we're still using Sage NDEC boxes, and I think maybe once I've had one not work. I'm not an SNMP expert, but you got to believe that Portainer and Linux, it's full of SNMP traps, hooks, controls that you could set up an alarm to to let you know, hey, this hasn't responded in 4 minutes. Maybe you ought to have a look at it.
Mike, you should have a Portainer running there on your container server where you run your VX.
The nice thing about that container server is nothing ever happens to it.
There you go.
Maybe I answered my own question.
Thank you, Kirk.
Well,
Yeah.
thanks for your attention. Hey, I got to give a shout out to John Lynch with BSW back here. They're tearing down. They're closing down here, and John was kind enough to give me some swag. So thank you, John.
Supposed to be a filler bomb. Grab me one.
Oh,
Don't forget. That's the hard way.
and of course you know what John gave me.
Oh, yeah. I saw him crawling around back there.
See, clowning around is right. That's right. All right. Well, thanks for inviting me. I appreciate you all very much. Good to see you all.
All right, thanks so much.
All right. Take care. Bye-bye.